Hi everyone, welcome to part 6 of lecture 11, and in this lecture we will discover some of random number of independent random variables. So that concept can be a little bit important to solve some kind of problems. So we'll try to discover that one. Suppose that we are given some random variables x1, x2 that can be infinitely many, and they are independent, identical distributed. And also we have another random variable, which is n, and that is a discrete random variables, and which is the independent of xi, and that is represent the number of random variables. And these random variables like can be exponential, geometric, Poisson, etc. But the important one is they should be independent and identical distributed. Okay. So, and let's define a new random variable y that is equal to summation of that independent random variables. And remember that xi is the independent of each other, and also this n is independent from the xi. Okay. So n is a new random variable here because when I change the n, the results will change. Okay. So the Adams law tells us the expected value of y, which is the summation of the random variables, is the expected value of the conditional expectation of the y. And also the Eve's laws tell us the variance of y, again, y is represent the summation of the independent random variables, is the expected value of conditional variance of y plus the variance of the conditional expectation of the y. Okay, so we have this piece of information. We will use these informations to make the further calculations. Okay, so now let's define. Okay, let's say we don't know how many random variables will be summed. Okay, so that is not for sure. That's not a constant. So that can be any number like 2, 3, 4, 500, etc. So the condition will be based on the number of random variables, like right. So I just want to calculate the expected value of y given the number of random variables. If that is, for example, 2, I will the y will be x1 plus x2. If n is 3, the y will be x1 plus x2 plus x3. Okay, so I just want to calculate that one. So what is the y? Y is the sum of xi, and indexes start from the 1 to the n. So it is from here, and the condition is n is some particular values. So because I know that one in the beforehand, because the n will be some particular values, I can change this capital N with the smaller n, right? So the question is, the asked question is expected value of the summation of xi given n is equal to some particular values. So, and I know that the x and n are independent. They will not affect each other. The increasing or decreasing the n will not the value of the x, right? So like summing 2 of them or 3 random variables will not affect the summation, the result or the value of the x ones, right? So they are independent from each other. That's why I can ignore that part, because that will not give us any extra information. So I can rewrite this guy, the expected value of y given n is equal to some particular value small n, which is equal to expected value of sum of xi, right? And I know that that will be something like, so they are independent and identical, right? So I know that the expected value of x1 is the expected value of x. The expected value of x2 is the expected value of x. How many random variables I have here? The n. So the expected value of summation of xi, which is equal to n times expected value of x. So this is in my hand. And if that is 2, for example, if n is 2, so that will be 2 times expected value of x. If that is 3, that will be 3 times expected value of x, right? So if that is n, the capital N, I can say that the expected value of y given n, which is equal to n times expected value of x. Okay. So so that is the first things we just figure out. And in summary, the n is independent from the xi, and if I want to calculate the conditional expectation of the y, and the condition is the number of random variables, that is the number of random variables times the expected value of the random variable, okay, the x. Okay, don't forget the x's are the identical independent, and that's why I write the expected value of x, because that they will be the same. Okay. Okay, let's look at the variance. If I want to calculate the variance of y under the condition n, I can, so what is the y? Y is the summation of the xi, right? And the condition is n, the number of random variables. And instead of this capital N, I can write the n because that will be given before, like as a number like 3, 5, etc. I can write the capital N. So that will be the variance of the summation of xi, given that n is equal to some particular values. Again, I can ignore that one because the x's and n are independent, so I can ignore them. That's mean the variance of y given n is equal to n is equal to variance of the summation of xi. Okay, because they are independent and identical, I can rewrite this part the n times variance of x. Okay. So the conditional variance of the y, which is equal to number of random variables times the variance of the random variables. So if the n is 2, that's the variance will be 2 variance of x. If that is 3, the variance of the conditional variance of y will be 3 times variance of x. If that is a capital N for the generic one, that will be the capital N times the variance of x. Okay, so that is the general equality. So we know that from the Adam's law, the expected value of y, which is equal to the expected value of the conditional expectation of the y, right? And we just calculated that one, which is equal to n times the expected value of x, right? And because these are the constant, I can rewrite that part as the expected value of n times the expected value of x. The y is not the depends on the x, which is the depends on the n. So I can rewrite that part as the expected value of n times expected value of x. So based on the Adam laws and what we found from these calculations, I can say that the expected value of y, which is equal to the expected value of n times expected value of x. Okay, and that makes sense, right? Because n is random variable, so that is not for constant. That's why I need to consider the expected value of it. That's not for sure. That should be some expectation. And remember that I say the expected value of y given n, which is equal to n times the expected value of x, right? And n is not for sure. N is not constant, and I don't know n. That's why it should be some expectation, the expected value of n times the expected value of x. So that makes sense under the case of the probability word. Okay. So that is the first equality. So when I look at the variance of y is we know from the law, the expectation of the conditional variance of y plus the variance of the conditional expectation of the y. We just calculated that one, the inside, which is the n times the variance of x, and also I know the expected value of y given n, so which is n times expected value of x, right? So here the variance of x is a constant, and that will not affect the result, so that can go outside the expectation, and simply I can rewrite this part as the variance of x times the expected value of n. That's guy. Okay, so just I got the variance of x, the outside of the expectation. So this first part will be the variance of x times expected value of n, plus let's look at that guy. That will be the variance of n times expected value of x. So here the expected value of x is a kind of the constant values, right? And remember that I need to take the square of that coefficients. So that's why I can rewrite this part as the expected value of x squared times the variance of n, right? So remember the variance will be I think I mentioned in the linear combination of the random variables like ax plus by, and that was the a square, the variance of x, plus the b square variance of y, right? So because that is the multiplication, so that is the coefficients, and you can consider that expected value of x as a. So that's why I will take the square of them. That's why I can rewrite that guy as the expected value of x squared times the variance of n. Okay, so that is the second things we just figure out, the variance of y, which is equal to variance of x times expected value of n plus the expected value of x squared times the variance of n. And the y is the summation of some number of random variables. Okay, so we have two things here. Again, please don't memorize these things. If you need, I will give you, just try to understand it. Okay, just try to make it concrete. And let me give you an example to show how we can use that one. Suppose that the number of accidents per week at an industrial plant is a Poisson random variable with the mean 4. Okay, and suppose also that the number of workers injured in each accident are independent random variables with a common mean of 2 and the variance of 1. So we have some random variables, and also we have the number of random variables, okay? Assume also that the number of workers injured in each accident is independent of the number of accidents that occur. So that if we look at like that, the n and x is independent. Okay, so so what is the expected number of injuries during a week, and what is the variance of the number of injuries during a week? So let's y denote the total number of injuries, okay, total number of injuries, and xi denote the number of injuries in the ith accident, right? Ith accident. So simply I can say that the y, which is the total number of injuries, will be sum of the injuries in the ith accident, right? And the number of accidents can be anything that will be a random variables, and that can be denoted by the n. And where n is the Poisson with rate 4 that is given to me. What we found that the expected value of y, let me show here, the expected value of y, which is equal to expected value of n times expected value of x, right? So, and what was the question? What is the expected number of injuries injuries during a week. So I just need to find the expected value of y, right? Because that denotes the total number of injuries. And the formulation I need to use is expected value of n times expected value of x. That is simply the average accident, and which is simply the average number of injuries. What is the expected value of n, which is given as 4, right? And what is the expected value of x, which is also given in question, which is 2. So it is simply 4 times 2 and 8. So the expected total number of injuries is 8. So what about the variance? The variance of y. Again, we just found the formulation. We can use that one. We just found. So the variance of y, which is equal to variance of x times expected value of n. So what is the variance of x, which is given in the question? That is 1. And what is the expected value of n? That is also given in the question. That is 4. And what is the expected value of x? That is also given in the question, which is 2. So 2 squared. And the variance of n. Variance of n, the n is the Poisson, so the variance is also the rate. So the variance of the variance of n is also the 4, so that will give me the 20. Okay, so the variance of y is 20. So we use we calculate the sum of the expected value of some number of random variables and the variance of some number of random variables in that way. Okay. Okay, so let's look at another example, which is again the minor example. And please remember the questions. There is a minor, and there are 3 doors. If he chooses the first door, he will just escape from the mine within 2 hours. If he chooses the second and the third door, he will spend 3 and 5 hours, and he will come back to the mine. And then again, he needs to choose another door. Okay. And the question is, what is the expectation and the variance of the length of the time until the miner reaches the safety, so the escape from the mine? We have already solved these questions, but now we will look at that questions from the different angle. Now let x denote the total time, okay? And the ti denote the time spent in the trial I. Here, the ti is 3 and 5 with the equal probabilities. Then x, the total time, I can define the total time as the sum of ti from 1 to n minus 1 plus 2. Why? Because in the last option, in the last choice, if he chooses the first door, he will escape. Like, you can think the first door as a success, and when I have the success first time, the process will be ended. That's why I can think the n as a geometric random variables. With the p, the probability of success is 1/3. And here, let's say he first chose the second door, okay, the second door, and then third door, and then the first door. So he will spend the time 3, 5, and 2. The total time will be 10 hours, right? So that's why the n is here, 3, and the number of failure is 2. Okay, that's why the index starts from 1 to 1 and goes to the n minus 1, because nth one is the success one, the first one. Okay, so after understanding this model, that is easy to solve. First, let's look at the expected value of x. So the expected value of x, we will use the formulation we just found in the previous slides. The expected value of n minus 1, times the expected value of t, Okay, so you can think the ti's are the random variables, and the n is the number of random variables. And here, instead of n, there is a n minus 1. That's why the expected value of x is equal to expected value of n minus 1 times the expected value of t plus 2. Because that's for sure, because the last door is the first door, and the duration for that door is the 2 hours. So what is the expected value of n minus 1? We know that n is a geometric random variable with the p is 1/3. So remember the expected value of the geometric distribution, which is 1/p. So 1/3 minus 1. 1 is from here, that's the constant. And times what is the expected value of t. T can take the 3 or 5, okay, because these are the failures one. The represent only the doors 2 and 3, and in that can be 3 hours or 5 hours with the equal probability. That's why I can calculate the expected value of t as 1/2 times 3 plus 5. Okay, and I have 2 here. So the expected value of x is 10 after doing some arithmetic. So that's the same as the previous one we have calculated in the previous parts. And let's look at the variance. And again, we will use this formulations. In these questions, the variance of x is equal to variance of t, which represent the random variables, times expected value of n minus 1, that is represent the number of random variables, plus the expected value of t squared times variance of n minus 1. Okay? Okay, so what is the variance of t? I think that is okay. So to calculate the variance of t, I can make this calculations, right? Expected value of t squared minus the expected value of t squared. Okay, let's first calculate the expected value of t squared, which is 1/2 times 3 squared, because the t can take, like, t can be 3 or 5 with the probability 1/2 and 1/2. If I want to calculate the expected value of t squared, it is simply just 3 squared times 1/2 plus 5 squared times 1/2, okay? So that is the first one. And how can I calculate the expected value of t squared? Because I have, I know the expected value of t is 1/2 times 3 plus 5, okay? And that is 4, and that will be 4 squared. Okay, and what is the expected value of n minus 1? I have just calculated from here, which is 1/3 minus 1, that is equal to 2. So, which is equal to 2, plus the expected value of t squared. So I have just calculated here, which is a 4 squared, and the variance of n minus 1. So n is a geometric distribution, right? And that constant values will not affect the variance. And we know the variance of the geometric distribution is qp squared. And we know that the p is 1/3. So the q is 2/3. So the variance of n minus 1 will be 2/3 divided by 1/3 squared. Okay? And the results will be 2 plus, so there is a mistake, 2 plus 96, and that is a 98. So the variance of x is 98. So we got the same results what we did in the previous parts. But that there is another way to calculate these questions, these kind of questions. You can always consider these ways as well. But in summary, we can say that we can sum some we can some number of random variables in an easy way, but always I need to remind you, you don't need to memorize all these formulations. I will just give you, or you can find from the some sources, but just try to understand the logic behind what we did. Okay, so if you have any questions like that, if you interested the summation of some random variables, you can apply these strategies in an easy way. Okay, so that is the end of part 6, and I will see you in the last part.